Welcome to EC Elimu Learning Simplified, and welcome to this lesson. Today we are going to introduce a new topic, the fourth topic in Form 1 called pressure. And we are going to realize that we use the word pressure almost daily without paying much attention on what its exact meaning. Now, in hospitals, sometimes nurses and doctors talk about blood pressure. In petrol stations, we add air pressure into the car tires. In the kitchen, we use pressure cookers. Sometimes psychologists and counselors talk about peer pressure. At work, people talk about pressure at work. But now in physics, we are going to define pressure in terms of force and area. So stay tuned. My name is Albert. I hope you will enjoy this topic. By the end of this lesson, I expect you to be able to define pressure and state its SI unit, and then derive a mathematical expression of pressure, which we are going to find as pressure is equals to force all over area. So you are going to derive that, and then finally calculate pressure in solids, and then state factors affecting pressure in solids, which are going to be force as the first factor, and then the other one will be area as the second factor affecting pressure in solids. So what is pressure? But before we define pressure, let's do a very small demonstration here. If you take soap, bar soap, this is soap, and then you take another piece here, then you take a nail, this is soap also, you take a nail like 2-inch nail, you put the blunt part of the nail here, and then the sharp part of the nail to be up there like that. And then what you do, you take a stone, and then put it on the sharp point of this nail. This is a stone. Observe what will happen. What will happen in this case, the nail will penetrate into the soap like this. There will be a very slight penetration here. The nail will penetrate slightly. It will penetrate slightly like that, and then much of it will be up there. Then your stone will be there like that. This is your stone. And then I want you to take the same nail on the same or a different bar soap. Here you have your soap, but in this time you put the nail in such a way that the blunt part is up there, and then the sharp part is down there, and then you place your stone up here. This is your stone. Then what will be observed? What will be observed is when you have your bar soap like this one, this is soap, the sharp part of the nail will penetrate deeply inside the soap. Now, of course, we have our stone here. It's our stone. Now, let's call this one setup A, and this one is setup B. Now, between setup A and setup B, where is large penetration? We are going to realize that in setup B, the nail penetrated deep than in setup A, where it just penetrated slightly. Now, I want you to look at the area. The area in contact in setup A and the area in contact in setup B. The area in setup A is large area. In setup B, the area is small area. So where we have small area, there is high penetration, and where we have large area, there is low penetration. Now, the pressing apirity or the penetrating apirity of a force is what we call pressure, and we define it as the force acting perpendicularly. Perpendicularly means 90 degrees to the surface. 90 degrees to the surface. Force acting perpendicularly per unit area. Now we can derive this equation as pressure is equals to force per area acting perpendicularly by unit area. Now the SI unit of force, we know it is Newton. Then the SI unit of area is square meter. Therefore, the SI unit of pressure will be square Newton per square meter. That will be the SI unit of pressure. Sometimes we have another submultiple of pressure, which is 1 Newton per square meter is the same as 1 Pascal. 1 Pascal, which is written as PA. So if you see we use these two units interchangeably, then you should know we are talking of the same thing. So penetration is high when there's low area, and then penetration is low when you have a large area. We calculate pressure from the formula that we get from the definition, that is pressure is equals to force acting perpendicularly per unit area, which we write as F over A. And now if we want now pressure is equals to force over area, if we want force alone, we can get force alone by just multiplying by A this side, and then now A in this side will cancel with this one, then we remain with F is equals to P times A. That is force is equals to pressure times area. Now if we need area, from the definition, pressure is equals to force over area, then we need area. What we do, we first multiply by A, then now A will cancel with A, then we will remain with A times P is equals to F. Now we want A, then we will divide by P, then now P and P will cancel, then we will remain with area is equals to force over pressure. So when you have this one formula, that is pressure is equals to force over area, you can be able to calculate any of the two. When you are given two of them, you can calculate any of them. So let's now do an example so that we see if we have understood the pressure, force, and area relationship. And the first question is a box of mass 500 kg. So we have mass is equals to 500 kg is placed on a table. If the area of contact of the table or in the table is area is equals to 2.5 square meter, then calculate the pressure it exerts on the table. Now calculate the pressure it exerts on the table. So we are looking for pressure, we have area, and then do we have weight? Let's write the formula. Pressure is equals to force over area. Now, do we have force here? No. But force, how do we calculate force? Force is equals to weight of the body, and the weight is equals to mass times gravity. So in this case, our force will be the same as weight, which is going to be 500 times, if we use our gravity as 10 newtons per kg, then in this case, our force is going to be 5,000 newtons. So that will be our force. Now we have force, we have area. Let's calculate pressure. Now in this case, it will be pressure is equals to force, which is 5,000 newtons, which is the same as the weight of this is the weight of the box, over area, which is 2.5 square meter. Remember, these two are in SI units. Then now our pressure is going to be 2,000 newtons per square meter. The units, you just take them from there, and then remember we said the SI unit of pressure is Newton per square meter, or sometimes we call it Pascal. So you can say pressure is the same as 2,000 Pascal, PA, like that. So what you do first, When you are given mass in kgs, you convert the mass to weight, and the weight now you get it as mass times gravitational constant, which is 10 on planet Earth. Then you use it as a force, then you calculate the pressure the box exerts on the table. Another question, a metallic block of mass is equals to 100 kgs exerts a pressure. We have pressure in this case. Pressure is equals to 20 newtons per square meter on a surface. Determine the area. We are now looking for area of contact between the box and the surface. So what you do first, you write the formula. Pressure is equals to force over area. Do I have a pressure? Yes, I have it in SI unit. Yes, newtons per square meter. Do I have force? No. But do I have mass? Yes. So the force here you will use as the weight of the box. And now weight is equals to mass times gravity, which is going to be 100 times 10. In this case, it will be in terms of newtons, which is going to be 1000 newtons. Then this is our force now. Then now, can we write the formula of pressure? Pressure is equals to force over area. Do we have pressure? Yes, we have pressure as 20. We have pressure, just a minute. We have pressure as 20 newtons per square meter is equals to force. Do we have force? Yes, 1000 Newton over area. Do we have area? That's what we are looking for. Now, for us to get area, then it means we multiply times area, where this side area will cancel out, and then we will remain with 20. Let me use a blue pen. We will remain with 20 newtons per square meter times area is equals to 1000 Newton. Then after this, you want area, then it means you will divide 20 newtons per square meter on both sides. 20 newtons per square meter, like that. Then we will remain, this one will cancel out. Then we will remain with area is equals to 1000 newtons times, remember what we discussed back there, how you change numerator and denominator. It will be times meter square over 20 Newton. Then now a Newton will cancel with a Newton. Then this 0 will go with this 0. And then 2 will go 1. 2 will go 50. Then our area now, our area of contact is going to be 50 units will be, it will be 50 units will be square meter. So in that case, the first thing you do, you convert the mass into weight, where you multiply by gravitational field strength, which is 10. Then you use that one as a force. Then area is what you are looking for. You have pressure, and then you solve it slowly, and then you get your answer as 50 square meter. So this is just a reminder of what we have been discussing, that whenever you have a force, or you want a force of a body or of a solid resting on a surface, you only need to get its weight. The weight of the body is the same as mass times the gravitational field strength, and mass times the gravitational field strength will be the same as the force of the body resting on that surface. So if I give you mass, then automatically I've given you the force which you are going to use to calculate pressure. So a single solid can give us different pressure depending on the area which is in contact, or the side which is in contact with the surface. For example, if you have a cuboid like this, you have a cuboid like this one here with a length, let's say it has a length of 3 meter, then width 4 meter, then it has a height of 2 meter. So in this case, this cuboid has 3 surface areas. It has that surface, it also has this surface, and of course it has this upper surface. So if, for example, we want to calculate, let's call them area 1, this is area 1. Let me use this ink. Area 1, area 2, and then area 3. If we want to calculate area 1, we will take length, which is 3 meter, times height, which is 2 meter, which is going to give us 6 meter square. Area 2, we are going to calculate it as 4 times 2, which is going to give us 80 meter square. Then area 3, we are going to calculate it as 4 times 3, which is going to give us 12 square meter. So if this body, let's say it is exerting a force of 20 newtons to the surface, then we can have 3 types of pressures. Pressure 1 using area 1, so pressure 1 will be 20 newtons over area 1, which is 6 square meter. So in this case, we will have 3.333 newtons per square meter. That is pressure 1. Pressure 2, we can calculate it as, since the body is the same, it exerting the same force, 20 newtons over 8 square meter, which is going to give us 2.5 newtons per square meter. Then this is pressure 2. Pressure 3, we are going to get it as same body, 20 newtons over area 3 now is 12 square meter, which is going to give us 1.667 newtons per square meter. Now look at pressure 1, pressure 2, and pressure 3. Which one is the highest? Pressure 1, we are using the smallest area. Smallest area is 6 meters square, followed by 8 meters square. Then the maximum area is 12 meter square. Now pressure 1, when we use area 1, which is the smallest area, it will give us a pressure of 3.33. Then we use an area of 8, it gives us 2.5, which is smaller than the first one. And then we use the area which is maximum 12 square meter, it gives us the maximum or the minimum pressure, which is 1.66. So this means for us to calculate maximum pressure, we will take the force or the weight of the body, then we divide by the minimum area. Force divided by the minimum area, the smallest area, it will give us maximum pressure maximum. Then if we need minimum area, then it means we will take the force, then we divide by the maximum area. If we need maximum pressure, we will use force over minimum. So here we can say maximum pressure is equals to force over area minimum. But if we need maximum or minimum pressure, we will take force over area maximum. So that one is very important. So we have two factors which affect pressure in solids, and the first one is area of contact with the solid surface. And in this case, we have seen that the larger the area, the smaller the pressure, and the smaller the area, the larger the pressure. And now, therefore, if you want to decrease the pressure, then you have to introduce a large surface area, and that one is applied on those vehicles which carry main roads. They have many wheels so that to increase the area in contact with the road. When the area in contact with the road is increased, the damage on the road is decreased, because large surface area means that vehicle will exert a small pressure on the road. So the second factor which affects pressure in solids is force, which is the same as the weight of the solid. And in this case, from the formula, pressure is equals to force over area. It means if force increase, then pressure will increase, and if force decrease, pressure will decrease. So since I handled one question back there concerning maximum and minimum pressure, I'm leaving you this question as an assignment so that you do it and test yourself if you have understood the concept of maximum and minimum pressure. So if you get any difficulties, kindly make a comment on the comment section below this video, or visit ECLIMU Learning Simplified and get more examples and solutions for such questions. So that marks the end of our lesson today. In the next lesson, we will discuss pressure in liquids and gases.